Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graph transformations. This is standard A.3E in the great state of Texas, and we are using item number 2 off the Redesign Practice online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got f of x equals x, and it was transformed to form g of x equal f of x minus 23. You know what? Let's open up our graph draw feature. Let's extend that out. I'm going to grab actually those equations. We're going to draw it because we can here. And so, you know what? Let's use the connect line feature. And let's just make a little coordinate grid here. Okay, so what do we know about this first line right here? I'm going to make it a little bit more transparent so we can see it. F of x equals x. Okay, so let's graph that, and I'll make that black. So when we have f of x equals x, that's that first one. Well, remember, we've got our x and our y. And what we're going to do here is we are going to just view this x as obviously our domain, right? But our y, that's going to be our f of x. That's the range. So it's 0, 0, right? So we're going right through the origin right there. And then we've got 1, 1, okay? And then 2, 2. So its direct variation is proportional, right? And it looks like it's got a slope. It's hidden right there. But the slope is 1 because the change in y over the change in x is just 1. All right, so we can easily graph that. All right, so let's see if I can. First, I'll just kind of connect it up this way to make sure we see it that way. And then I'll kind of extend it down this way. And you notice that for every y, I'm changing the x1. Okay, that's my f of x equals x. Now, the other one is g of x equals f of x minus 23. Okay, so that's a little bit different. Let's change that here. So I've got, let's get back to our draw line here. G of x equals f of x minus 23. Now that's kind of a strange formation. We're going to take this f of x, this black line, and we're going to transform it somehow. But you notice that my f of x is equal to x. Okay, so I'm just going to replace this f of x with x. Since those two are equal, I can substitute them. So g of x is going to equal x minus 23. Well, this looks very similar to my slope-intercept form. Y equals mx plus b. What's my slope? Well, my slope hasn't changed. My slope is still 1. Okay, what has changed? Well, now got a pretty nasty y-intercept. That's what that is. That's the y-intercept. And that's a negative 23. So my slope is still 1. So all I did to transform this particular graph is we're going to slide it down. We're going to slide it down 23. Okay? So we're going to go down 23. And then let's pretend, obviously this is not counting by ones. Let's pretend this is negative 23. Well, once we do that, if we pretend that that point is negative 23, well, then we have the exact same line, right? We're just going to connect it there. I'll extend it down this way. The line is exactly the same. What's the difference? I shifted it down 23 because it has a y-intercept of negative 23. So that's what I did. Let's see if we can find that here. The graphs at f and g are not parallel, and the graph is translated up. They are not parallel or parallel. That's the first thing. Well, those two are parallel. I just shifted it down. So it's not going to be A or B. C says they are parallel, but it's translated up. D says parallel translated down. That's what I'm looking for.